Hey, Sophia. I'm going to do 1D. In 1C, we figured out that the volume is this integral. Just they gave us the rate f, and so we integrate f. Now, what's important in this question is that the variable is h. So in question 3, the variable is the height. The height's at 5. But notice that when they do d, they've changed the variable to time. They tell you how fast the height's going up. I think it's 0.26, something meters per second or something like that. So we know that if we want the derivative, of the volume, right? We want to find out how fast the volume is changing. That's the question. So we want the derivative of the integral, and we know the basic rule of thumb is if you take the derivative of the integral, it cancels out. You just get that function. You just get you put the f in. You put the h in, and here's the key to the question. It's times h prime. Remember, you have to do a chain rule on whatever is there, or in other words, you can have the integral from 0. So whoa, sorry, not the integral. Hold on one second. Let me erase that. Remember the derivative of this is back to f, but in C it wanted the variable to be h, and in D they're changing the variable of the rate of change to time. So when you put the h in, you have to do the derivative of h, and then or you could write it like this. It doesn't matter. The AP exam would be comfortable with either of these. Plus x times, h. This new board doesn't really erase real well, unfortunately, but such is life. So, e to the point 2h plus h times h prime. Now, we want to, what the question wants to know, what is this going to be at 5? Now, when I put the 5 in, we also are told earlier in the question that I think that's 0.26. We're told how fast the height is going up. So I end up then getting, now you need your calculator, of course, to do this. Do the 0.2 times 5 plus 5 times 0.6. And if you work that calculation out, you get 1.694. Just to remember, if I have volume, which we got from C, what we want to do then is we want to take the derivative, and then again we know that the derivative of the integral, you just put the h in, but you also have to take the derivative of h, because we're switching the variable to time. If it stayed in h, like the question 3, then we would just do f of h. But because they told us the height's going up at 0.26 like meters per second, we need to do a chain rule on that to get that answer. Hopefully that answers your question.